Hello Primary 6A, Primary 6B, Primary 6-7, Primary 7A and Primary 7B. Mrs Allen here again to do your last part of your coding. We're going to be looking at binary coding this week and I will explain more in a second. Our aim this week is to understand what binary coding is and why we use it. This screen shows a row of binary numbers. Binary numbers look like this. Binary numbers are binary code. Binary numbers or binary code are used by computers and digital devices to talk to each other. It is used to give commands to the computer or a way to enter data or information. We use the alphabet to write letters or words to communicate. However, computers use binary code. This is a note of the binary alphabet. This binary alphabet means that instead of writing the letter A, computers would write numbers. For example, A would be represented as 01000001 and so on. Binary numbers are always 8 digits long and are only made up of zeros and ones. How does binary work? Firstly, you need to understand our number system. Our number system is called base 10 or the decimal number system. This means that we can only use any of these 10 numbers to create any numbers we need. Base 10. As soon as we get to the number 10, we need to add another digit into the left of our current digit. For example, 1 and 0. We need to add 1 onto the 0 to make 10, as there are 10 numbers in our number system. Every time we make a new column, it has to be 10 times greater than the number before. This is using 10 symbols. But what if we only had 2 symbols to work with? Base 2 binary is the same as base 10, except that every number to the left is only 2 times bigger rather than 10 times bigger than the number before it. Counting binary. Have a look at this table. A binary sequence like this would equal 155. Now would be a good point to pause the video to see if you can figure out how you can use the table to work out why it would only equal 155. You need to use multiplication to work out the answer. 1 times 128 equals 128, 0 times 64 equals 0, 0 times 32 equals 0, 16 times 1 equals 16, 1 times 8 equals 8, 4 times 0 equals 0, 1 times 2 equals 2, and 1 times 1 equals 1. After you've worked out the multiplications, you then need to use addition. Adding each of the answers, 128, add 0, add 0, add 16, add 8, add 0, add 2, and finally adding 1 will give you the total of 155. Computer circuits. All computers have circuits that allow electricity to pass through them. A microchip is a group of tiny circuits that help a computer or other digital devices to work. Electricity is needed for computers to work. Binary code tells the circuits when to turn the different parts of the computer on or off. On was represented by 1 and off was represented by 0. Did you know, in the early days of computing, the only way to enter data into a computer was by flicking switches, or by feeding in punched cards or punched paper tape. The first computer was created by Charles Babbage in 1837. It was operated using punched cards and tapes. He called it the analytical engine. Modern computers still read data in binary form because it is much faster and more convenient to read this from microchips. Now it is your turn. Attached to this PowerPoint you will find some tasks based at mild, medium and spicy. Have a go at the different tasks, but remember to challenge yourself within your learning and do the task that is best suited to your level of ability. Thank you.